Hello, good morning. Good morning. Good to see you all here. Nearly full room. I hope you'll enjoy the next talk. It is by James Munnelly, the author of Cert Manager. Do you know Cert Manager? Many of you use it? And do you know Kind? Do you use Kind? Ben Elder is the author of Kind. And Ben and James are going to talk about testing with Kind. Some of it will be a little bit about what you do for Cert Manager, right, James?
Yep.
Yeah, cool. Yeah. So just wondering, like, how many of you use Kubernetes in production and think that you have your testing story sorted out? Okay. Yeah. But like generally, how many of you use it in production and such? All right, okay, cool. And how many of you first time at KubeCon? Oh. Brilliant, okay, cool. Well, welcome all the new timers and the old timers, and over to James and Ben.
There you go. Yeah, thanks very much for coming today. This is a very, very full room, and I can still see more and more people coming in. We're going to be talking about testing Kubernetes applications using Kind today. And a bit more generally too. So first of all, what is a Kubernetes application? I realize that it's kind of a very loose concept. We could be talking about anything. So it's pretty much anything that runs in Kubernetes, but we're going to be putting a big focus on extensions and controllers today in this talk. So who here has kind of looked at running operators, extending Kubernetes, anything like that? Yeah? Nice, like Kube Builder and Operator SDK. Yeah, so this is a good talk for you. So yeah, different types of tests, first of all, is something I'd like to define, because I think the difference between unit tests, integration tests, end-to-end tests, it's kind of a very undefined thing. I've never really come up with a good strict definition. So I'll start by saying unit tests, they typically would make use of something called the fake client in Client Go. It's effectively an in-memory implementation of the Kubernetes API server and client. It works great, but it does have a lot of caveats. It's very simple. You don't get the full admission control chain on the API server side. You don't have additional controllers running. You're missing quite a lot, but it's great for quick, simple unit testing. Yeah, one big thing that I found is that race conditions, timing issues with the actual controller reconciling and having to run multiple times, you don't pick up on that. So yeah, it's great. It's very good for testing kind of state machine style actions, you know, given this input state, what is the output? But it doesn't really test the whole system as a whole. Something like this. This is an example from Cert Manager's code base. We obviously build more packages around it, but in short, you can see here the difference is we've got this challenge presented true is the starting state, and then we actually check, we have expected actions. So here, I don't know if might even have a pointer. Nope, I don't have a pointer. But you can see here, we've got the new update action, so we're expecting an update to be we're expecting an update to happen. That's like against the API server. And we're expecting that state to be set to false. So you can see here, given that input state, we expect running the reconcile function once that we'll end out with a different output state. So then integration tests. So who's used Kube Builder here or looked at it? A few? OK. So within Kube Builder, they actually provide a load of extra testing functionality. So it will give you a bit of a framework that will start up etcd and an API server, and optionally, I think even a controller manager on your local machine. Compared to unit testing, that does give you admission control. We now have an actual API server running. We can pick up on timing issues, because this is kind of a bare bones, I'm not going to say Kubernetes cluster, but bare bones Kubernetes control plane right there. So that's, yeah, they work brilliant, and it gets you to the next stage. But there are more things out there to test than, well, there's more to it than that. Sometimes with all these kind of integration unit tests, you find yourself tying yourself to the implementation of your particular controller rather than the actual behavior that you're looking for. So that's where end-to-end tests sort of come in. And I'm sure we've all heard the term end-to-end tests. What we mean here is actually bringing up a Kubernetes cluster, deploying your application, and actually encoding what we expect and want users to be doing into our test. So saying, if I apply this, I expect that after some amount of time, 2 pods will exist. And the Kubernetes code base is full of end-to-end tests. You've got conformance tests, all sorts. And these are very black box. You go and apply something, and then you wait to see what happens. And if it doesn't do that, then that's a failed test. It gives us a lot of flexibility. You're really looking at this from the user's point of view, and they're really valuable to have. Yeah, it's black box, everything else. The one downside here is we need a whole Kubernetes cluster, and there are lots of different ways to start Kubernetes, run Kubernetes. You could spin up a cluster on a cloud provider or something like that and run tests against there, but over time, if you're doing this on every pull request or every change, that gets more and more expensive. I think the Kubernetes project itself does so by running, standing up GCE clusters for a while, which again, costs money. All of it's slow. I think, Ben, you probably know it's probably about, was it an hour and 15 to actually go through that whole process?
Yeah, most tests on Kubernetes pull requests take about an hour plus to run.
Yeah. So you can see that's kind of, if you want your fast iterative feedback loop, that doesn't quite cut it. As a developer, I have never run that test suite from my own local machine because I don't really want to dig into how to do it, and I also don't really want to run some cloud VMs for that period of time. And also, yeah, who pays for that? So yeah, why end-to-end tests though? Some of these edge cases, some of these problems only come up in a real environment. So you don't actually get to see issues with, say, running out of memory because your application's done so. Like, there's all sorts in there that you might not pick up on. And yeah, the way that other components in Kubernetes interact with your own application as well can make a massive difference. Something that passes unit and integration tests in isolation, all of a sudden you realize that one other core Kubernetes component is fighting against you. And so you end up with this flapping back and forth. And that can go on forever, and that will either generate tons of logs, use loads of memory, or it's just doing the wrong thing. We're just causing excessive load on our clusters. So without end-to-end tests, at least I've found, everything looks like theoretically it's perfect, but users are opening issues saying, like, you kind of just killed my API server. Nothing will continue running. I can't start pods anymore. So a bit of an example of where this came in really helpful. In Cert Manager recently, we've gone and refactored some API types. We needed to make sure that as part of that refactoring, we didn't break the old API format. So I started out by implementing the changes, so actually implementing the new format of API. I didn't touch a single thing in our end-to-end test suite. I pushed all that code up, or ran it locally, ran the test suite locally, and made sure that those tests still passed. And because they are black box, they don't understand the actual implementation, what's going on. If they pass, from my point of view, that's like I just ran users just sat there and ran this same flow. And the fact that that passed gave me confidence to know that I could actually move forward with doing this. Of course, I then went and added new tests at the end because you can't just add new functionality. But yeah, you gradually grow and grow your test suite. And as you're doing that, it builds your confidence, and it just means you can actually ship faster. We've done this countless times before the test suite, and where you think everything's perfect, it turns out it's not quite so much. Yeah, as it says, they give you confidence to ship. Without it, who knows what will happen. So that leads us on to kind. So we've been talking a lot about how difficult it is to get these clusters. Ben, I think you've got something to say.
So hopefully James has convinced you that end-to-end tests are definitely something you should be thinking about. And if you're thinking about end-to-end tests, you should think about kind. Kind is Kubernetes and Docker. So we run Docker containers to simulate nodes. It does multi-node, multi-cluster, works offline if you pull the node image first. And if you're booting a single node with the image pre-pulled, it should take about 30 seconds to boot up a node. So this takes away a lot of those problems, and it hits these key goals we want. If you're going to be doing testing, ideally, as much as possible, you want it to be fast so you get that iteration cycle. You want to be lightweight so that you don't mind running it all the time. We want to be cross-platform so developers can run it on their machines, doesn't matter where they're at. We want to be hermetic, which is a term I mostly heard at Google, but the idea being that we don't want external dependencies because those will decrease the reliability of your tests. You just want to be testing your application, not the internet. So, Kind is a testing tool, typical workflow, boot a cluster, build your application, and then sideload application images. We're going to come back to that. You don't have to do it this way. We're going to recommend that. Then you run your tests, do it again. Creating a cluster is just kind create cluster. You need the kind binary, and you need Docker. That's it. Sometimes you might want custom configuration. If you're doing this with kind, you can configure the entire kube interface. It's kube underneath. We have customized patches, which we're going to show in a second. And so you can configure anything you need to make Kubernetes look like how you want it to look. And that can just include things like changing the service cider or enabling alpha features, anything that you'd expect to be able to do with a fairly real cluster. So this is an example actually from some assert managers testing. So what you're seeing here is kind's own configuration. So we've got this just config object, I believe it's cluster now. And so we've got one node, and on that node we're saying we need to patch the kubeatum config to set a particular service net because kind is, cert manager is doing some fun things with networking because they're doing like DNS challenges and whatnot. So they're very particular about which subnets things are on. So you can just configure like that, very simple. Or if you want a bunch of nodes, you can have multiple control planes. We'll set up a load balancer container and do HA. And you can have workers, and you can simulate doing like rolling things across your cluster between nodes. And if you want to do things like, okay, kind ships its own lightweight CNI, but I wanted to integrate with Weave, then you can disable the default CNI, deploy your own. So now that you got your cluster up and ready to go, what you're going to want to do is load your image into it. And the idea here is, again, avoiding flakiness, avoiding being not hermetic, no dependency on the internet. Instead of pushing your image to a registry in your testing flow, what you can do is you can build it, and then you can tell kind to load it into all the nodes. And so basically, it's just going to take a Docker archive of your images, and then stream those to all the nodes and load it in, so that when you tell Kubernetes to run your image in a deployment, it's already present. It doesn't need a full. You don't need to use the internet. You can do this offline. So now you're going to get the kube config. Kind generates a unique kube config for each cluster. So you can ask kind where the kube config is, point kube config environment variable at that, run your tests. Now James is going to do a live demo. I'm sure this will go smoothly.
Yeah. Cool. Let's see. Hopefully, go a little bit bigger. Hopefully at the back you'll be able to see. So in this demo, I'm actually going to deploy the sample controller from the Kubernetes code base. So this is just a really basic example. I've put together a very, very basic run test script. So here we can see we do, first of all, a little bit of cleanup, because I had to do a bit of testing here. And then we're using this kind create cluster command that Ben mentioned earlier. We'll go into and have a look at that config file in a second. But once that's run, just like Ben showed, we go and get the kube config path. Notice here that we're passing a name variable. This is because we can run multiple clusters at once. So for example, the Federation v2 project, they utilize kind to actually test federating multiple clusters together. They pass different names for each one, and yeah. And that all runs on one machine. Here, we then go and build our application. So obviously it depends on what you're doing here, but in our example, we're doing sample controller. We build a Docker image for it. And then just like Ben said, we load the Docker image into the node. Now if there were multiple nodes, I think in this example, we're only going to do a single one. That would actually get loaded into every single one of those nodes, so it's available for use. We deploy the sample controller, and then we'll start using it. So enough looking at scripts. Let's bite the bullet and see how this goes. So do a bit of cleanup, and here we go. Kind is going along, and it's creating a cluster. So we're booting version 1.14.2. This is just using one of the pre-packaged ones that Ben has pushed up for everyone. It prepares the nodes first of all, so that's creating the containers. It then goes and initializes kubeadm. It applies all those patches that we've specified onto a base config. And then it will start actually initializing. So that under the hood is running kubeadm init within a container. We've already gone and configured systemd, Docker, and the like. And there we go. We installed a CNI, and the cluster's up and running. So we're on to the next bit. Our script's going. We've built sample controller there. It's going a little bit too quick. And we're building a Docker image containing it. And you can see here, we've gone and loaded that image into the kind container. And we've gone ahead and actually deployed the sample controller. So in your application here, obviously, the manifest you use, the commands you run will be slightly different. We're just trying to illustrate what a typical workflow would look like there. At the end, we've actually gone and managed to deploy one of our foo resources. This is an example. It's not particularly useful. And you can see we've got our command to run here. And this is, as Ben said, hopefully you can see at the back. This here is the kubeconfig file that kind is created. This is typical, works with everything. Everything that works with kubectl. And we can now go ahead and check our cluster. There we go. So we can see, just like any other Kubernetes cluster that you're used to, we've got all the different components. We've got our CNI here. We actually run a custom lightweight CNI. That's perfect just for testing on a single host, because we know where we're running. We can understand the network topology better. And we've actually got our example application here. Our sample controller here. So as you kind of continue to build, now that we've got a cluster up and running, you can continuously run that kind load Docker image command and load more and more images into your nodes when you roll out changes, and then just restart that pod and off you go. So this gives us not only a testing environment, but also a development environment. Here I'm running it on my laptop, but this could have run on CI, and it will be identical. The fact that it is identical is so valuable. Like, if you have varying different environments between different developers and everything else, it's frustrating. You go, you see your tests are failing, but you can't possibly actually debug it because you don't know where to start. You don't know how to actually get this up and running. So, yeah. I will clarify, we've not written a full test suite here. This isn't telling you how to write tests in Bash. Please don't write your tests in Bash. Anyone?
Really don't, please.
Yeah. So it looks like it didn't go wrong. Yeah, so we are running here, kind in on my laptop. We do support running kind, obviously, in various different CI platforms. Just put together a kind CI/examples repository. So that's coming together gradually. We currently have some examples for running kind on Circle CI and Travis, gradually adding more there. But technically, anything that's Linux, you're pretty good to go. Or Linux, OS X, or Windows, I should say.
Probably the most fun that's not in this repo yet is Kubernetes' own CI, which is, of course, running on Kubernetes. So we run Kubernetes on Kubernetes, because who wouldn't want to do that?
Yeah. You can go many layers deep. Yeah, and one extra thing to note, here we've kind of used the CLI side of kind. We do also try and, we want kind as itself to be consumable as a library within Golang. So here's an example where we actually go and create a cluster all in code. Now, anyone who's familiar with Golang testing, you can just go and chuck this into your test functions and stand up a cluster that's used for a single test. And that, you can see the clusters boot within about 30 seconds, but we can actually just bring up a cluster for each individual test, which means that you know that if it passes once, it should pass again and again, because the cluster bring up is, as Ben said, hermetic. So we know we don't depend on any external sources. And yeah, no more Bash.
So I'm going to talk about what's next. We're hoping to get better network management. We found that we want it to work perfectly everywhere, but one thing that is actually different for everyone is your local DNS on your host, and that gets picked up by Kind right now. We're figuring out what to do. We'd love to hear ideas. IPv6 support and testing. So Kind was actually originally written for Kubernetes testing of Kubernetes, the project, and we don't have any IPv6 CI. So we're working on getting IPv6 worked out in Kind so we can get single stack, and then next will be dual stack as Kubernetes starts to grow that. We want to make node ports easier to access on Mac and Windows. This is a bit of a caveat for application development now. If you're on Linux, all of the nodes have IPs, as you would expect, that you can reach because they're just Docker containers on the Docker bridge. But on Mac and Windows, they're inside like the Docker for Mac VM, which doesn't expose one. So you'll have to port forward, and we're still figuring out the best option there. We'd love to hear feedback there. We want to make it easier for you to build like an exact Kubernetes version, but cheaply. Kubernetes' own CI is building tarballs all the time that you can just download at like whatever version you want. So we want to just take that, pack it into a kind image, and then you can run it. We're always trying to make things faster. We have a few more ideas there. And we're trying to move from alpha to beta very soon, hopefully. But if you use a released version, we promise we won't break you. And I'd really love to hear from any of you, your use cases and like what features you'd like to see, because it's a small project right now, but there seems to be a lot of attention. We're trying to figure out what to prioritize, so appreciate that. Here's where you can contact us. This is under the SIG testing and the Kubernetes sub-project. We have a bi-weekly project meeting on Zoom, like most Kubernetes projects. We're on the SIG testing mailing list, and we have our own Slack channel on the Kubernetes Slack. You get an invite at slack.k8s.io, the repo at sigs.k8s.io/kind, which is also, you can just go get that if you have Go modules on. And the docs are at kind.sigs.k8s.io. Thanks for coming, and I want to do a special shout out to Liz Frost at Heptio, who actually put together the CFP but couldn't come, and to James for jumping in and helping square this away, rework the talk a bit, and pitch in. And thanks everyone for coming.
Thank you very much. And thanks for making Kind such an awesome project. Well, we do have plenty of time for questions, actually. Yeah, please raise your hands and I'll run over to you with a mic. Okay, so we got 2 hands here, 1 there. Okay. Let's start here.
Yeah, IPv6 support hasn't been merged already in the kind, or it still exists as an extra PR?
It's in a PR. It's almost there. I'm going to be reviewing that some more when I get back.
I mean, could you be a bit more specific for the time when it's going to get merged? It's kind of important. I mean,
we're hoping,
it was at the same state about a month ago, so...
Right, it was for about 2 months. We had a bunch of other chaos going on, and we got back to that. We've had a lot of progress on it recently, but we're not quite there. We're very close. It turns out one of the components we're using is not working in IPv6 properly. We're going to swap that out, and then I think we're good to go. But it is a bit of a filling one. Yeah, when it's ready, we're hoping for another release about a month from the end of KubeCon. We try to do monthly releases. We did a release just before KubeCon, so hopefully that one.
Okay, and sorry, second one, very short one. Let's say if my PR is actually changes the API server, what would be my workflow to use basically to use the custom API server image when your cluster comes up?
Kubernetes PR?
Yeah.
You just need to do /test pull Kubernetes kind E2E with hyphens between them, and we've got an optional pre-submit now. We're hoping to probably make that a default one soon.
Okay. You had the second question?
Do you have a plan to support creating image registries and shared volumes such as NFS or iSCSI along with creating the cluster?
I'm sorry, I'm not sure I understood the question.
When I create cluster, I want to create a registry as well, so I can test pushing images from Kubernetes using Tekton or Knative build. And I also want to create shared volumes such as NFS or iSCSI target along with the cluster.
So we do have support for adding extra volumes to the nodes to pass through things. We do not have any special support for registries right now, but it is something we're tracking.
I'll just go in order that people raise hands. 1, 2.
Is it possible to use kind with another container runtime, like containerd or cryo or something like this?
Using kind with other container runtime on the host.
Not yet. We're looking at that. So that's a big thing that we want to do probably after we finish the IPv6 stuff is refactor out so that we're not talking to Dockers in many places, and we have like a little kind of CRA shim for unit testing, and Podman will be the next one. We're targeting CRI functionality as much as possible, like we don't use excessively Docker-specific things where we can avoid it, but it will take some time. Yeah. We're big fans of that. We're running containerd on the nodes now because we've been able to do a number of optimizations around how the boot up happens because of that, and I'd like to see more of that.
Cool. All right, one more question here, and then next one there, okay.
Since you're suggesting that we should use it as a library and not use bash, and you're still alpha, do you have any plans on how you're doing versioning with Kubernetes? For example, you have a project using 1.12. Yeah, typically, if you're in GKE or something, you're a little bit behind. So any plans on how to do that in future?
Possibly using replace. That's a really tough one, and that's part of why we focus on the command line first, because yeah, that one's tricky. One solution is to just have your test suite import this, and hopefully your test suite can be decoupled enough to just talk to your application, and then you can version that separately.
Yeah, I think that comes about kind of from the black box nature. For example, our test suite never really touches any core application code. It is basically its own application. We compile that to its own binary.
Okay.
I would like to ask, is it possible to deploy images using Helm?
You mean the Docker images or deploying the applications on it?
Yes.
So I mean, you can use Helm against the cluster, Helm and Tiller against the cluster that you're deploying to. In fact, Cert Manager does exactly that, so we can verify that our Helm charts also work as part of our end-to-end testing flow. The Docker image side of things, I don't think that's something that Helm does generally anyway, publishing images using Helm. I think it's more as the deployment, although lots of things change in this space quite rapidly, so I'll disclaimer that.
Okay, thank you.
Okay, we do have plenty of time for questions still. Any more questions on this side?
One down at the front.
One down in front, all right.
If we already use Prow as a CI, would you recommend a starting path to use kind?
You should send one of us a ping. We do have that set up, but it is a little bit hairy. Might give you a hand with that.
To clarify, we use Prow as well, and yeah, have been running kind in there for quite a while now. You just need to make sure you make your pods privileged enough.
Okay.
If nothing else, kind's own pre-submits are on Prow, so we can point you to that.
Mm-hmm. Another question here, okay.
Hi. Any plans or work already being done to use kind as a library from other languages?
I think
Great
not.
question.
I think not. I'm hoping that, I mean, so the command line is meant to be used from these things, but that's an interesting topic. There's a bit of logic in the kind library to do some of the setup. We have to do things like generate the config, or like, we used to do more things during boot up to control that. We've moved a lot more of it to be basically just running the image, but there are a few things that we have to set up and configure and whatnot. We basically probably have to like rewrite the kind aspect in another language. And yeah.
I think maybe over time, it could be more possible if we manage to reduce the amount of stuff that kind itself has to do until we, like, if we can just get it to the point of a Docker run. I mean, I guess you can write Docker run in Python or something.
But perhaps I was thinking maybe that there's the kind cluster API provider which turns kind into something that you can access with cluster API, and after that you could use any other any client, any Kubernetes client potentially to do things with it. I can't speak of the maturity of the project or anything like that.
We have actually discussed that. It gets a little goofy because right now Cluster API uses kind to bootstrap by default, so we'd be like bootstrapping kind with kind, but sure.
Theoretical, purely theoretical idea. So there's another question here.
Yes, I was wondering how do you approach, or if you have any plan to approach, the problem of external dependencies. For instance, let's say the case I declared a PVC using a storage class, which is an AWS storage class because I've got an K8s managed cluster, or I'm using an ALB ingress controller, or even I'm using an external database, let's say DynamoDB still too.
So you would want to sort of mock it out?
Storage is a particularly tricky one with kind. I think you can install a fake storage class that pretends to be the same. But like on some level, when you start to get pretty far in those things, I would recommend like you have a QA pass at some point further in the dev cycle where you actually run in a more prod-like environment and make sure that everything works out as you expect there. Because storage is one of those points where like if you're not specifying many things, it's going to work great and be exactly the same everywhere. But if you start tuning things and whatnot, it's going to be a little bit different. That's hard to avoid.
Okay. More questions, please. We've got 5 more minutes. Okay, one over there. I'll try to come over. I'll come from this side. Oh, right. You're right down the middle. Okay. Somebody could pass this along, please.
Hello. I have a question more about testing operators and how you do this internally with kind, and particularly with eventual consistency. So the problem we are having is our operators are just eventually consistent. So you run into like flapping tests because you have a time limit set. How do you handle this internally, or do you have any advice to deal with this?
Yeah, that's a great question. We had a good discussion about this the other day, me and some colleagues. So, like you say, unit tests don't really pick that up because you run a reconcile function once, and actually things are eventually consistent. We need to keep going. This is where I'd say kind really shines, because obviously you are running your controller. You are doing that whole thing. You do need to be careful to maybe count the number of times it takes to get to your finally consistent state, or how long. And that can generally be handled quite well with test timeouts and the like. I think some of the other strategies on a more like unit testy level could be considering running kind of the reconcile function in a for loop up to 10 times, 15 times, 20 times, whatever is appropriate for your code. Yeah, that's what I'd say for the eventually consistent things. But with kind itself, you do kind of want to do this in a larger cluster, because it may be that you're not actually getting to your consistent state because something else is fighting you, basically.
Does kind give you an ability to restart your entire Kubernetes environment between tests or between test suites?
Do you mean reusing the same cluster, or?
Like, let's suppose that I want to clear my state between the test suites and maybe clear some kind of database state. Would it be possible to restart it programmatically?
We actually recommend just throwing away the cluster and making another one. It'll take you about 30 seconds to boot a cluster.
But like, would it be done in an external script, or is it like, can it be coded into my test?
Like in your test harness, like, okay, so these set of tests are going to run with this cluster, and then this set of tests are going to use a new one. Just spin one up, tear it down. Tear down is near instantaneous. It will take you a second or two, and up is about 30 seconds. So if you really want that clean state, there's no better way than just actually having a clean slate.
Right, thanks.
Okay. Someone here had a question? Was it one of you? No? Okay. All right.
If that's all the question, oh, no, there's one there.
Yeah, I can see. Sorry, could you raise your hand again, please? Where you were? Okay.
So time to ask?
Really quickly, I want to hijack stage here. Anyone who has sent us a PR, would you come up? I know there are a bunch of people are here. I see you, Antonio.
Okay, the question would be, you mentioned that you also run on Windows. So using Kind as a dev environment for like a prod-like environment to work on Kubernetes on Windows, is it possible, or what are the major problems surrounding this when using Kind?
It should run fine because it's just using Docker containers. That said, we don't support Windows nodes yet, but we do support Windows as a host. It's a little bit not quite as well supported because we don't have CI for it yet, and I don't develop from it, but I do periodically check and make sure, and we avoid anything that's operating system specific on the host side.
Okay, thanks.
Thank you. Thanks very much, everyone.